All right, welcome everyone to the Solana Validator Educational Workshop. Thanks for joining. Today we're going to be talking about logs as a validator, especially logs related to starting up your validator. So what does it mean when you see a bunch of different logs happening as your validator starts up and tries to catch up to the network? So I'll hand this off to Steve, our Labs team. Steve works on the Ledger tool at Solana Labs, among a lot of other things, and has a lot of great insights on what happens when your validator starts up. He'll be working off of this gist, which I'll put in the notes as well. So let me do that right now. Here we go. Put that in the chat. And yeah, I'll stop my share, hand it over to Steve, let him introduce himself, and then get started. Go ahead, Steve.
Cool, thanks, Tim. Let me get my machine sharing. Can you guys see that? And is that big enough?
Yeah, I think pretty good.
All right, cool. Well, yeah, Tim mentioned I'm a engineer on with Solana Labs. I work on the core validator. steviez, or yeah, as you can see, my GitHub and Discord match, so I see me. But yeah, in any case, yeah, I feel like there's typically like a good amount of questions around startup. You know, what's happening? Why does it take so long? Why is my node not catching up? Etc. So, you know, we have some tooling in play like Ketchup, like Solana Ketchup and Solana Validator. Monitor command try to address some of these, are like shed some light into what's going on, but they don't necessarily paint the whole picture. You know, part of it's you know, it'd be really invasive to the code base to try to pipe status, you know, down to every subfunction. So, you know, unfortunately, the monitor command is kind of more broad strokes as opposed to the logs, where we can log every little minute detail. So this document covers a bunch of log snippets, and we'll just kind of run through like what like, you know, when I'm looking at like a validator restart, you know, when I'm trying to like figure out what's going on with mine, you know, I'll you know, grep for these log statements, and you know, they'll kind of tell me like how far along it is, you know, if I'm in a time crunch or something's not looking right. So yeah, just these notes at the top are pretty much just administrative things. It's like the default Solana log, Solana equals info for the Rust log. I added the hardware config in case people are looking at timing, just, you know, as a comparison. And then yeah, I tried to leave some comments here to around the log. So you know, in this case, the slides will be posted. So you know, if you come back, you can look at it. But oh yeah, and then I guess the last thing, maybe this is mostly default setup. In terms of like accounts are not on a RAM disk, they're just on regular disk. And I also put the accounts index on disk, which in 1.14 is not the default, but moving forward, that will be the default. So again, I don't think we'll be too focused on timing here. This is more about just like what things are happening, but just mentioning that because I imagine people might look at timing. But so yeah, first one, this one's pretty simple, Solana Validator. Oh, I guess other note, just please stop me if questions come up. You know, I'd rather answer them in line as opposed to letting a mess up at the end, if you know, when we change topics. But yeah, first one, pretty straightforward. Solana Validator spits out the version. So this one's useful. This will real quickly, like if you grep this one in your logs, if you see a bunch of instances of this means your node's boot looping, so something's up, whether it's you know, panicking, ooming, some bad flags, whatever. This is just like a good sanity check. It's also nice to, you know, if you're like upgrading, you know, I think pretty recently we've seen like a handful of people getting the 1.14.7 versus 1.14.17. So like, this is just like a good sanity check. Like this will tell you what's running. You know, maybe your startup script is doing some manipulation to your path, or something under the hood that forget. But this is just a good sanity check. And then this also is kind of like T0 for startup process. So this next bit, I mean, yeah, there's like a handful of minor things that happen. Like we'll clean, it's like some cleanup from last run, like some basic network stuff. But kind of the next big one, which a useful log that I find is this one. If you go after like loading bank from full snapshot, this gets emitted right before unpacking snapshots. And the thing I like about it is it also tells you what your latest full and whether you have a incremental. If you're familiar with the Rust option, this is a sum with the path. But if you don't have any incrementals, then that will be a none. So that's just like sometimes a good sanity check, like especially if you're downloading fresh snapshots from the network. If you don't get an incremental, there's a good chance your node's going to be pretty far behind right out of the gate, just because most operators have increased their full snapshot interval, or the default's like 25K slots. So if you don't get an incremental, there's a good chance your node's going to be struggling for a while to repair and catch up that up to 25K gap. So yeah, shortly after that, yeah, this is 706. So shortly after, we get into this the unpack of the snapshots. So we've recognized the latest snapshots, so now we've got to start unpacking them. And this just spits out how many unpacking entries. In this case, entries more or less line up with a slot. And as it is right now, you can see there's about a 10-second delta. There's 4 lines that are pretty evenly spaced. That's because there's 4 threads doing the unpack here. So they're each doing, like, in this case, they've each done like 10,000. So this is like 41,000 entries total unpacked so far. And then the reporting loop is every 10 seconds. So now, this was at 706.48. Now it's 10 seconds later at 58. Making progress. So you'll see these come up, but this is one of the first big things that takes a while. Actually, I think if you guys are familiar with the monitor command, there's like the loading ledger step that, I've heard the feedback that, there's like a little bit of a black box, what's happening. This is like unpacking the snapshots, kind of the start of this, but like unpacking the snapshot and like getting the bank parsed from the snapshot is kind of the beginning of like the black box, so to speak. But in this case, we're unpacking a 40 gigabyte archive. So it's just a lot of time. But zooming ahead a little bit, so these will keep getting emitted every 10 seconds. And then here we finally hit the end. So each thread's unpacked about 100,000 entries. So there's 4 of them, so that's like 420,000. These for fulls, these are typically about on the order of an epoch, and that's just based on like what like how often like slots are like updated with like rent. So like each account has like an update like once an epoch if it's checked for rent. So yeah, we see this took 96 seconds on my machine, so minute and a half, pretty decent chunk of time.
Yeah, talk a little bit about sorry, Steve, what that unpack is actually doing. Is it just putting it on disk and untarring it?
Yeah, exactly. So the snapshots, as I'm sure everybody here is familiar, snapshots are kind of like your save point. So if your node's running, you capture a snapshot at slot X. Even if your node progresses to X plus 50, if you stop and restart, you go back to sorry, I just noticed this to do here. Don't worry about that. But your unpack you start back from slot X, and it's a tarball. It's a compressed tarball by default. Like the .tar.cst. So this unpacking is just extracting the contents of that that file onto disk in an uncompressed format.
Cool, thanks.
Yeah, Chris there, yeah. Yes, the unpack is done when the untar, this untar message took, or is emitted, yeah. Yep, no problem. So yeah, moving along, there's actually, in this case, as I showed earlier, this line, so I had, my node does have a full and an incremental. So similar process is repeated for the incremental. Incrementals are much smaller. You know, if you just run ls on your machine, this will be you know, immediately obvious to you. You know, the fulls are like 40 gig and the incrementals like, you know, 1 gig or something. But this one you see it completes much faster. Oh, what the hell? There's I'm looking, there's like looks like I have some notes that didn't update in here, but okay. Anyway, that to do, I was like pretty sure I addressed it. But anyways, I'll just spitball through here. So yeah, at this point we have an incremental and we have a full snapshot unpacks. Like we basically have what we need. So we don't have a bank yet, but we have like all of the underlying files. So kind of the next step that happens is we run through essentially like all these files that are now in disk, which is like basically accounts DB, and we regenerate the state for the to like rebuild like our bank status and like essentially reestablish this like state at whatever the snapshot slot was. There's actually not that many exciting logs in this area. It's just like, it's kind of just a background scan of like everything we have just unpacked on disk. I think right now there's like 130 gigabytes if you look at the accounts directory, something on that order. So in the same vein, I don't think we don't read all 130 gigabytes of that data, but you know, it's more like established, like reading like metadata from files, and there's like a piece of accounts DB, like a subset of it is called accounts index, and that's kind of like a map into like the underlying accounts DB stores, and so like we regenerate that, and you know, just you know, for whatever the account state size is right at the moment. Oh, thanks, Tim. Let me just okay, I guess let me reshare that tab if I don't see the to-do. Oh, okay, cool. Let me reshare. Yeah, sorry about this. Where is this? Oh, what the hell? Google Chrome.
Controls are not easy to find.
Yeah, they're actually, I don't want to, Chrome is getting mad at me about permissions. Would you mind just sharing the link here, Tim?
Sure, yeah, I can do that.
We'll just, instead of having everybody watch me fumble on the call here.
Yeah, sure. Just let me know when to go up
Scroll.
and down. 1 sec.
Yeah.
I think you were around here-ish.
Yep. So we had unpacked the incremental there. So the that line, begin the creation of initial bank accounts DB. So that's kind of what I was talking about there. So it's like that snapshot version is emitted. There's 2 there, one for the full, one for the incremental. And then that line like loading bank from full snapshot, which is kind of similar to the log line above, but it's just getting emitted in a slightly different spot. And there's a longer message that you scroll to the right, but it's not, yeah, nothing really too important there. Just the same thing, the snapshot names. So in between there and the like the bank rebuild finished. So there's the accounts DB index generation. That's the part I was talking about there. I actually showed what some of those log lines look like, where we're you know, showing progress through index generation. But otherwise, there's just like a lot of background stuff going. But like, yeah, like I said, we're basically just scanning, you know, this 130 gigabytes of unpacked state. We do like a hash on it to make sure that the state we just reestablished is valid. You know, obviously, if you get like there's a hash that's stored within the archive. So like we have that hash, and then we like recompute this hash for like the account state based on the scan, and we compare those. If those don't match, then we obviously either have a bug in the software or a corrupted archive, and then you know we would not expect things to go well from there. So there's just like a lot of sanity checks that happen out of the gate, and so it takes a while, but it's like just making sure that we're restarting in a good state, because otherwise things will just go haywire afterwards. But in any case, that's you know, that line there, bank rebuild finished. You know, this is like that next step you see, like it took I guess just over 3 minutes. And so that kind of marks like the end of like when we've reestablished a bank and it's seemingly in a sane state. And I include that slot number there. You know, that's the same snapshot slot, the incremental snapshot slot from before. Moving down, yeah, the next one, bank frozen. So you'll see these everywhere in just steady states too. This is when a bank, or I guess to back up, you know, when you have a slot that you're considering, you know, if you get some, you know, if you get the block for you know, some slot from the leader, we create a bank internally, and the bank is the term we use in the code base to like represent the state and like the changes that are introduced in that slot. And so a bank is frozen when it's when we've completed the slot or when we've completed replaying the block. A slight elaboration here: when you download a snapshot at slot X, you don't actually replay the block for slot X. Like the snapshot itself is the state after the block at the snapshot slot has been played. So maybe I was a little confusing there, but hopefully you guys understand the distinction. Like the snapshot is at, you know, the end of that slot. You know, and all transactions have been replayed. So at this point, yeah, we have a bank. We have like a full account state generated and like in, you know, memory and disk at our snapshot slot. So the next step is we start replaying ledger that we have locally. So, you know, in that example I gave earlier, you know, maybe your node made it to like, you know, 50 slots past your last snapshot slot. You know, and this is going to replay those, and that replay should fly by pretty quickly. But these logs kind of get emitted at the start, and they point out that first one there, like processing ledger from the slot. That's the same as the snapshot slot, and then the one after tells you the halt point for like how far it will go. So ledger holds data through slot 18 something or another. It's off the screen right now, but it's probably like 50, yeah, 32. Oh, okay. So in this case, it's like 1,000 slots. Yeah, going there, I called out that log statement, bank fork set root. So this is a log that will get emitted both at steady state and startup. So this is just the node identifying that like the cluster has confirmed a block. And so this is done, in this case, this is identified by replaying blocks and seeing votes and knowing the stake weights of people voting. And you know, you're able to recognize that. Tim, your question there, could you be in a case where you have a gap between full snapshot end and incremental start? No. So like incremental snapshots are essentially like you can think of them as like a delta based on top of a full snapshot. So like you always need a full snapshot, and then like, the incremental is almost like a, like a diff, for how many ever slots later. So those are like, just by construction, those are like compatible. Does that
Okay,
answer the
makes
question,
sense.
Tim?
Yeah. I'm wondering, I guess, if you download from an external validator, if there's a chance of getting that gap. But it sounds like you would get both the incremental and the full from the same one that has kind of the pair.
Yeah, exactly. I think you either download both from them, or like if you have a set of nodes, like I think the known validators that Labs has in the that like everybody has in their startup script, I think those all run with like the same intervals. So I think those are actually producing snapshots at the same slots. So you could get like a full from BV1, but then actually get the incremental from like BV3.
Makes sense.
Cool. So kind of the next log there. So yeah, that bank fork one's is just a little more of an aside than anything. But after that, so that's called out the local ledger replay progress. So this is where we're actually going through the blocks. And there's you see those log lines: processing ledger. So that tells you the latest slot. It tells you, just some basic things, but I think maybe the interesting bit there is like the slots per second. So that just shows you that it's actually churning through these slots, at a decent clip. This, this continues to get faster in better versions, or in higher versions too. Like master's quicker than 14, 14's quicker than 13. So this has been an area that we've had gains in, but have yet to be realized. There's also a note there. You see I left the annotation there. This is where v.1.13 restart is slow with an existing ledger. I guess we can actually, if you scroll down a little bit, Tim, past the end of the logs there, yeah, that part that's kind of like, whited out. So like, I think probably some operators have observed and commented that sometimes it's faster to reboot when you just completely wipe the local ledger, or like even just like wipe the RocksDB. And the reason that is like there's I want to call it a bug, but just like the design between 1.14 or 1.13 and 1.14 or later differs, and it basically has to do with like resource reclaim. So like in 1.13, as you're replaying these slots, you're accumulating these banks. And calling the bank is like the state for like a given slot, and these banks, they're pretty large footprint in terms of resources, like i.e. memory. And so you essentially we need to reclaim these as we go along. If you let them just pile up, we're gonna memory usage will climb, and like maybe there wouldn't be enough slots to make you out of memory, but it's like better to bound it and be sure that you won't out of memory in the scenario. And so the reclaim process happens in a manner that like blocks or like the account's background cleanup is actually what it's doing. But this cleanup process, it happens in a manner that like blocks replay progress in v.1.13. Whereas in v1.14, the cleanup is done asynchronously in the background. So that cleanup is able to be handled while replay progress continues. So that's just like a, just a fundamental design thing where 1.14 is just superior. And I guess one other note there, that blocking thing that happened, that's like only in the startup path, like this local ledger replay at startup. That doesn't happen in the like steady state, because obviously that would be very, very bad. So it's just like a slight improvement that came along with 1.14 and later. But anyways, scrolling back up a little bit more. So yeah, there's those processing ledger, maybe a little bit down. Thanks, Tim. Those processing ledgers, those get emitted, it looks like every 2 seconds at the moment. And then eventually you'll see this last one, that ledger processed in ... And that's that marks the end of when you've finished replaying all the slots that you recognize were already on disk. And so that it's a pretty lengthy spit out, but like it'll tell you your latest route, how many active banks you have, like, you know, maybe banks that are on the main fork but have not been rooted yet, or maybe banks that are on side forks but have yet to be determined that they're not the main fork yet. Yeah, spits the time spent, and yeah, after that, there's just like a little more initialization. You'll see like, but at that point, basically the validator is like up and like ready to like be like part of the network and like, you know, responding and like catching up. So you see like the timestamps there are like fractional, you know, it looks like 2/100ths of a second apart from finishing the local ledger replay to validator initialized. And that, yeah, that validator initialized is just like a log right at the end of the validator struct, you know, right before new returns. Yeah, I guess I'll pause there for a sec. Does anybody have any questions about logs, these logs? Because if not, we'll move on shortly to like looking at some metrics that kind of explain like catch up progress. Yeah.
Could you describe what replay block means?
I'm sorry, once more.
Describe what replay a block means.
Yeah. So yeah, replaying a block. You have a in this case, we have all the blocks that we're going to replay are already on disk. So like I was saying before, this example, like, you know, maybe our node was running, we created a snapshot, we progressed 50 slots past, but then we restart. So those 50 slots are available on disk. So we're not network bound like we are in steady state, like waiting for things, but essentially we recall the block from the block store. So there's an entry point in the block store API that says, go get me this slot and get me all the entire block. In the block store, things are stored as shreds, which are like the network size pieces of a block. You know, those are what are sent across Turbine, but essentially they're just like an implementation detail of how we propagate you know, pieces of the blocks and then like reassemble and store them on disk. So replaying a block is, you know, if we have the full block, we're just going to get all of them, and we'll you know, shreds are serialized chunks of a block. So we'll basically deserialize those back into like the underlying transactions, and then we'll take that whole set of transactions for that given slot, and we'll just run them back through the runtime. So just basically like re-execute them, look at, you know, mark whatever state changes occur, you know, which like updating accounts or, you know, moving LAMP ports or, you know, whatever. And we'll like acknowledge all those changes kind of in like a temporary cache in like our bank, that, you know, that bank object I described earlier, and kind of like store those up and like acknowledge that state changed. Was that clear, Chris, or any other? And I might have been using. Hopefully, I wasn't using like words to you know, like hopefully I wasn't using block to define block there.
No, I think it's clear.
Okay.
I'll go back and think about it a little bit more, but that was helpful. Thanks.
Okay, cool.
Maybe something that would be helpful, Steve, from
Yep.
our chat earlier is, you know, I had a general idea of what restarting looks like, but clarifying a little bit more about like when you restart from a snapshot, you blow away accounts, and then just start from scratch there, and like why that happens.
Yeah, that's a good point. Yeah, so the like snapshots are, as it is today on Solana, like you can think of them as like a save point, you know, in a video game. So like, you know, if you create a snapshot at some slot, that snapshot contains like the worldview the world view of like Solana account states at that slot. And so like, I guess when you restart, just based on like, it's kind of an implementation detail, but essentially we don't try to start from like our previous accounts directory. And it has to do, I mean, I guess the underlying detail there is that we use like a lot of like memory maps, and there's just like things that are in memory, things that are on disk. And if like your node dies from like a panic or an or even just a regular restart, getting like the account state consistent, like knowing what was in memory and made it to disk, or like what was in disk, like it's kind of like a just potential for race conditions. And so I guess up to this point it was just designed instead of having to trying to be able to restart from the unpacked account state we had previously. We just blow it all away and start by unpacking the snapshot, unpacking the contents of that snapshot archive over again. As the number of accounts has increased and the size of snapshots has gone up, this is maybe something that we, it's probably not as efficient. And I think we have, I think both somebody external, or I have heard of somebody external to labs looking into like the idea of, well, both somebody external labs and I think somebody within labs have been like looking at, can we adjust the code to know like, when the validator shuts down, like know exactly what was persisted on disk, and instead of like blowing away the accounts directory, like unpacking that snapshot, which you saw took like, it's just like a minute and a half just to do like the untar, basically like just trying to jump straight into like the step of doing that scan over the existing account state and restarting there, or being able to rebuild a consistent like set of data structures from that. But yeah, that is very much like prototyping ideation. So as of now, and like 1.13, 1.14, like 1.16, it's still blow away the account state and drop in a fresh copy from the snapshot to restart.
Cool, thank you.
Yep. If there's no other questions on this at the moment, we can scroll down a little bit more. All right, so yeah, just this. I tried to type this out just so that people are looking at this after the fact. But yeah, I'm just kind of summarizing this quickly. So yeah, after that last log line earlier, validator knew like the validator's up. So this will be the point when like if you're running the Solana validator monitor subcommand, like it'll show like your current state. It will periodically ping an RPC node, and it will tell you your latest slot versus their latest slot. So it'll tell you you're this many slots behind. It's just kind of like that little like very, very small like mission control like view. And so like you could just like sit there and watch monitor. Hopefully the numbers or the gap is shrinking, and you eventually catch up. Maybe you're 2,000 behind. Hopefully it dwindles down. But like I guess that's it gives an instantaneous view, but like it's not easy to see like the entire timeline on the command line there. And so metrics help kind of paint like a broader picture into what's going on here. So this next paragraph there, it kind of just explains, but the graph there, it's a replay metric. It's just like every time we replay a slot or block, within that slot, we emit a metric that's like it has a lot of timings that are useful for debugging, but in this case, we're really just interested in the actual slot number that's getting emitted, because as we start playing higher slots, that means we're progressing. So we don't really care about all the sub timings there. But in any case, so yeah, looking at this graph, the cyan trace is from, it's like that, like really light blue. That was from another node that was running. That was from another node that was running against the cluster, and it was keeping up. So that it's included in this graph basically to just serve as like a reference point. The purple trace is the node that was running that like I had all the log snippets from above. And so, looking at that, so just a couple things to note there. It's like marker one, they're at like 713. So, it's discontinuous there because the node was not running previously, and replay stage starts up once the validator is like up and running. So that kind of explains the discontinuity. And then in terms of the difference on the y-axis, that's basically the how far we are behind the cluster. So the cyan trace is with the tip of the cluster. Unfortunately, our metrics dashboard, it's kind of goofy. We've complained to Influx about this, about like not being able to see precise numbers, but I didn't do the trace. But yeah, essentially, I mean, just visually you can see that there's a gap. And so something interesting to note here. So yeah, I dropped all these vertical markers in, and so there's like the vertical marker 1 and the vertical marker 2, and then I drew like that horizontal line across. And so what that horizontal line is trying to indicate is that so like when the node is offline, it's missing out on turbine. You're not getting like all the shreds in the or the slot, the blocks. You're not getting them in the most efficient manner. And so basically what happens is that like when the node restarts and you're behind, if you don't have those blocks, you have to use what's called repair, the repair protocol. And repair is, where like turbine is like max efficiency, like just blast things out over UDP. We have like some redundancy with erasure coding shreds, and then the hope is that everybody's able to collect the full slot. If it's actually the case where you could use repair at steady state if like if turbine doesn't work, like if there's like a hole in the retransmission network or whatever. I guess I don't want that's like talking about like turbine is like a whole nother topic in itself, so I won't go too deep. But essentially here you can imagine it like if your node is up and running at steady state, it's getting the blocks over through turbine, and it's like pretty efficient. But when your node's offline, obviously if you missed 50 slots, that turbine is a one-time thing. So you have to use this protocol called repair. And what repair does is like you essentially just query nodes. You say, hey, like how many slots, or which slots should I ask for? And then you have to, it's more of like a, like a traditional thing, like you ask for some shreds, and then the node sends them to you, and you acknowledge them. And so I guess it's more controlled in that manner, but it's also less efficient. And so what's happening here? So from like that vertical marker 1 to like the vertical marker 2, in terms of like the progress that like our node is making, like the purple trace, those are all slots that had to be repaired. And so repair isn't necessarily the most it's not as efficient as turbine. So like I think we've observed in this instance like replay stage, so like trying to like actually process transactions and update account state. It's like stalled out by getting these shreds from over the network again. So the interesting thing there is like once we get up to the vertical marker 2, that's like we hit this point where our node, like we've repaired all the slots that came across the network while we were offline, aka like the slots we didn't get. And now we're at a point where we're replaying slots that we were online for, but they were like very, very distant compared to like our latest state of processing. So like just to like maybe try to help illustrate this, like let's say our node starts 1,000 slots before the behind the tip of the cluster, we have to ask for those 1,000 slots from other nodes and gradually replay them. But in the time it takes to ask for and replay those 1,000 slots, the cluster has also progressed. And while we haven't actually, like we're not replaying those slots yet, those ones in the distance that like the cluster is doing while we're repairing, but we at least have them on disk. And so since we have them on disk, once we get to that marker 2, we essentially have like a big backlog of blocks that we can start replaying and like not be like essentially like replay can just like spin through without hitting network or like replay is not starved waiting for stuff to come over the network. It just has like I said, this large backlog of slots. So there's like a bit of an inflection point in terms of velocity there. Looks like some questions came through. Many cases I've seen the validator fall further behind the cluster while waiting for repair shreds. I guess a question there would be like what, like how far behind was the node? Like how far behind did it start in that instance? I don't know if you can, I think anybody can unmute, right, Tim?
I think
Sorry, I was
so.
muted.
I
Yeah,
think I'm
everyone
unmuted.
should. Yeah.
Yeah, and I've seen a lot of variation over
Yep.
the year of running node, so it's the behavior's changed. But I've seen many times when you finish replaying and you're initialized, you'll be, I don't know, for example, 700 slots behind. And I think while you're waiting for those repair shreds, you might fall further behind like 1,000, and then you start catching up.
Yeah. Yeah, and I think that's like the case of like your terminology was correct there. It's like you're trying to repair the slots that you don't have, and that's like not a quick thing, but like the kind of like I don't know, like not technically sound like terminology, but I'd say like that period from like 1 to 2 on this chart, it's like your node's just like trying to hang on. It's like it's making some gradual progress, but it's like just like catch up and get to the point where you're starting to replay slots that you got over turbine again. So like you'll actually see too, like that period from 1 to 2 is like a resource intensive area. Like memory usage will be up, like CPU should be up, like it's just that's kind of like a stressful point for the validator running. But like once it gets to 2, it's able to kind of go like full blast, and like it will start replaying slots much quicker. So like resources are going to get like reclaimed much quicker, and eventually to the point where you're reaching steady state. I mean, a good way of thinking about it too is like when you're, actually from like marker 1 to marker 3 all the way on the right, you're replaying slots faster than the cluster, right? Because you were behind, but you're catching up. So like kind of is intuitive that you're using more resources and stressing your node more because you're doing more in less time. But that period 1 to 2 is especially kind of like stressful in terms of like the node using more resources, and I think in previous versions that maybe weren't as robust or as efficient, you could see like an out of memory happen there. I don't think we as much anymore. I haven't seen any reports recently, but just in general, yeah, that is like a a spot. It's a window you want to be as short as possible, and you want your node to get out of as fast as possible, which is why like minimizing downtime is super important, and that's something that we continue to work at. Obviously, as an operator, you can do your best to, I'm sure probably all the operators in here, you stop your node and restart it immediately, within seconds. And so that's good. But then, more so on the engineering side, it's just minimizing the amount of time that a node is down, or the amount of time that a node takes to reinitialize. From kind of like that timeline of all the logs that I ran through earlier.
So is it fair to say, Steve, that between 1 and 2, you're doing double work, right? You're kind of getting shreds from turbine that are in the future, let's say, that you haven't
Mhm.
replayed yet, and then you're also doing repair. So you're like, is that why it's so resource intensive?
There's like double work in the sense of like you're writing the same amount of like stuff to disk. You're not replaying double work yet. So you're only replaying what is available and like on the contiguous like blockchain. So you're basically you're replaying slots as you are as they are made available to you via repair. And so I'd say it's more resource intensive in this fact that like just like yeah, it's like you're, but yeah, in that case, like I said, yeah, you point out correctly, like you're writing shreds that are coming through repair, and you're writing shreds that are coming through turbine. So like you're processing like, maybe not double, but maybe like 1.5 times the load of like blocks. And so like those shreds are all being like SIG verified. Those are all going to disk. So like there's yeah, there's like an increase in that sense. But in terms of like actual like execution of transactions, that's that if anything, that's a little lower. But once from like 2 to 3, it kind of flips. So like from between 2 and 3, we're not repairing anymore. It's like this point we're still getting turbine from beyond marker 3, but we're no longer repairing. Or if we're repairing very minimally, we're repairing at like the steady state level as opposed to like this restart level. And so that's less load in that sense.
Is there any kind of indication, like, because I've been doing Git health calls to kind of
Mhm.
monitor that process, but I don't think it's apparent there, but is there any indication in the logs when we hit number 2, like repair is done?
Not really. I mean, not directly. I'd say like one log you can look at, or I mean, this is a metric, but if you have metrics in your logs, you can look at it. But there's a one called shred insert is full, and that one will say like how many it'll tell you like how many shreds there were for a slot, and then it'll also tell you like the breakdown of like their source, the source being whether they were over turbine, whether they were recovered. I think I mentioned there's like we do the erasure coding for redundancy. So if they were obtained through that, or if they were repaired, repair being this this process of explicitly asking for them. And so like you can look at like the metrics for your own node to see, or I guess you can grep these logs too, but like it's a little goofy to look at because like when you're in that region from 1 to 2, you're going to have like slots getting inserted for things below that horizontal red line, but you're also going to have stuff getting inserted for like where the cyan trace is, because like it's like you're getting old stuff and new stuff, so like the logs are kind of like interleaved, versus like steady state, it's mostly monotonic. It's like you insert new slots, like you insert, typically you insert slot X before you insert slot X plus 1. But like, and that 1 to 2 area, you're going to be inserting like X and X plus 100, and then then X plus 1, then X plus 101. Does that make sense? Like kind of like that, the jumping around there.
Yeah, that makes sense.
Okay. But yeah, short answer, no. Like it's that inflection point is kind of, yeah, it's not clearly called out in logs. I mean, if I think if anything, like if you're trying to like monitor, if you happen to be sitting in front of your computer, I memean, actually, not, I guess you could like look. You can maybe do like a couple steps, right? So there's like that validator initialized log I spit out. So you could look at that, and then you could try to like cross-reference that with like where the you could try to cross-reference that with like where the cluster was at that timestamp, and then you could say, okay, like I need to get to this point before my node will start getting this like this nice rapid startup. But that's kind of a it's it's not obvious. It's not obvious that you need to do this, and it's not a nice thing. So I don't know. Maybe there's an area for improvement in like the logging there, but yeah, at this point, if I'm doing this, I just grind through it because I know what to look for. But I guess for operators, it's certainly not obvious at all. So understand that that's something that could be of value.
You know from the logs what snapshot the incremental was at, right?
Yes.
Yeah, so I guess you would know at least some of the info, like where it starts and then where your ledger was from that point, right?
Yeah. So like, yeah, those are all called out like in these logs. So like, there's like that loading bank from ... That will tell you the full snapshot slot and the incremental snapshot slot, and then that one there that's already in sight, like second from the bottom, ledger processed in, that will tell you how far you made it. Actually, the one even below it, the local ledger replay complete, that will tell you like how far you made it in the local ledger replay. Like that, it's off the screen because it's a long line, but like essentially, yeah, it shows you like the latest route, and then like those are all like the working banks. It's like the slots that are it has yet to be determined whether they'll make the main fork or whether they're not on the main fork. Just based on like the voting like lockout distance.
Cool. Any other questions for Steve?
Quick question. I don't know if this is the right form, but if a node enters vote only mode, is there something that will show up in the logs to indicate that? I mean, I imagine there is. But is there something we can look for?
I believe there is. Yeah. I don't remember it offhand. But I think, yeah, I'm pretty sure that happens in either. Yeah. Let me scribble on my somewhere. Yeah, I will try to. I should be able to look that up. But yeah, I think there is like a like an info or a warn that gets emitted.
Okay, thanks.
All right, well, we're almost at the hour. No other questions. I'll end it there. Thanks very much to Steve for joining and walking us through all that. I'll put this on YouTube soon and then include all the notes and the chat in the link so people have some context when they're reviewing it.
Yeah, I'd say too, like if you have questions like on like that, I think that the gist you can comment like on there. So yeah, you can leave comments there. So like if you have specific questions about that, like feel free. I think I get email notifications whenever you do. So yeah.
Cool. Great. Thanks a lot, Steve. And thanks everyone for joining. Bye.